of the take-home exam, we are given the following. A non-isothermal batch reactor can be described by the following equations. dc dt equals negative e to the negative 10 over t plus 273 all times c. And that's following dt equation. Whereas c in gigamoles per liter is the concentration of the reactant, and T is in degrees Celsius. A regression constant Tb is also given, as well as an initial temperature of 16 degrees Celsius. The initial concentration is given C as 1.0 gigamoles per liter. The constant A is given as 1000, and the Tb is given as 20 degrees Celsius. The problem asks us to provide an equation to solve for the concentration and temperature of the reactor as a function of time within 5 hours. We use both Euler's method and the predictor-corrector method with time step of t equals 0.1 hours. We then plotted the result with the two methods in one figure, one for the concentration and one for temperature. Then we plotted the absolute difference of the Euler and the predictor for temperature and concentration.
For the concentration differential equation, we decided that we needed to create some sort of for loop in order to explain in a plot the concentration versus time. To do this, we took a interval of 0.1, a dt of 0.1, and created a time vector from 0 to 5 hours using this dt. The yc of 1 and the ypc of 1 are the initial conditions, and they were both 1.
Using the for loop, we created an indexing vector I from 1 to the length of t, which is dependent on the delta t given. For the Euler method, we use the standard Euler method equation, which is a condition given plus the delta t times the equation, or the differential equation for f. We then use the predictor method in the same for loop because it uses the same initial conditions as well as length conditions. And the predictor method required us to find a predictor value as well as then plug it back into the predictor-corrector equation. We then used this for loop as well to find the difference between these two methods. When we were done, we then plotted each figure. The first plot was of time against the Euler method, and it was denoted using blue dots. And then we continued to plot time versus the predictor-corrector method with green plus signs, and then titles and axis labels were then given.
For the second plot, we needed to figure out the difference between the two methods and plot this against the time. And when we did this, we took the y difference of the absolute value of the Euler method minus the predictor correction method, and when we did this, we ended up getting a plot that looked something like this, and the maximum difference occurred at about 1.5, and figure 1 represents the Euler method and the predictor-corrector method graphs of time versus the concentration, and you can see they're both pretty similar in this case.
In order to solve part A for the temperature differential equation, we first stated our givens as well as our interval dt. We then used a for loop to evaluate the Euler method, the predictor method, and the difference. First, with the Euler method, we used the standard Euler equation, which required a given value plus our interval times the differential equation. The predictor method is then used first to find a predictor based on our differential equation and our interval, and then takes somewhat of an average of the two different predictor methods in order to find a more accurate version of the prediction. And then in this for loop as well, we found our difference, which was the absolute value of our Euler method minus our predictor-corrector method.
We used blue circles for that, and for the temperature predictor-corrector method, we used green plus signs. When you run it, you can see in figure 1, the plus signs represent the predictor-corrector method, and the blue dots represents the Euler method. And for figure 2, this is the difference between the Euler and the predictor-corrector method.
For problem 2b of the take-home exam, we were instructed to write a script using a while loop to find the required delta t that makes the difference between the Euler and the predictor-corrector method in terms of the temperature below a certain standard. The criteria used to evaluate the difference of the sum was the temperature of the Euler minus the temperature from the predictor divided by the temperature predictor, and then the absolute value of the difference over the predictor. This was done for each temperature result point. We first started with a delta t at a step size of 0.1 and had to reduce it by 0.001 each time. We then had to find the delta t that makes the criteria smaller than 10 to the second. Actually, here you see 10 to the negative 4th. However, this was an error and we had to find it 10 to the negative 2. The script we wrote reported the required delta t value and also plotted the criteria versus step time delta t.
In order to find a delta t that makes a difference between the Euler predictor-corrector method in terms of temperature below a certain critical standard, we needed to use a while loop and a for loop, and the for loop needed to be inside the while loop in order to accomplish this. Before the while loop, we set our variables, e, which was like the error or the critical value, equal to 1, which just needed to be greater than 0.01, and we set our dt equal to 0.1, which was stated in the problem. Before the for loop, inside the while loop, we needed to create our interval of t from 0 with the interval dt to 5 hours, and this interval size changed as dt got smaller. And for the Euler and the predictor-corrector method, they both had an initial value of 16. Inside the while loop, we needed to create a for loop in order to find the difference. Inside the for loop, we used the exact same equations as we used in the previous temperature method, evaluating the temperature Euler and temperature predictor-corrector methods. And once we did that, outside of the for loop, still inside the while loop, we need to create what our critical value was going to represent, and that was the absolute value of the Euler method minus the predictor-corrector method divided by the predictor-corrector method. And also inside the while loop, but outside the for loop, we need to establish that dt was getting smaller by 10 to the minus 3 each time. Once we did this, we plotted inside the while loop in order to create a point each time that the while loop was evaluated. And in order to do this, we used a hold on function so that each time it iterated the function, it plotted without deleting it. And when I run this script, it creates a plot, and you can see as the time step shrinks, so does the error in temperature difference. That also shrinks until you get the time step of 0.01, which was what we were looking for. So yes, those were our solutions to problem 2 of the first exam, the take-home exam, and we hope you enjoyed our video.